All right, what's up, guys? In this video, I'm going to pick up with some multivariable calculus, and we're going to be talking about double integrals, and we're going to be converting the following double integral that we have here in polar coordinates and evaluating it after that. So we're given this double integral e to the x squared plus y squared dA, and basically what they want us to do is to convert this integral in polar coordinates and evaluate it. And D here is just a disk centered at the origin. So let me just quickly remind you about polar coordinates. All right, so remember for polar coordinates that x is equal to r cosine theta, y is equal to r sine theta, and remember that r squared is equal to x squared plus y squared. And remember that dA is going to be r dr d theta. It's very important that you remember that dA is r dr d theta and not dr d theta. A lot of times students is, for dA, they'll put dr d theta. No, dA is r dr d theta. So make sure you don't forget about that r. That's very important. You'll end up getting the answer wrong if you leave the r out. All right, so just wanted to clarify that. And again, we're given a disk, so we already know what the ranges are going to be. So the ranges, in this case for theta, will be from 0 to 2 pi. And then the range for r will be from 0 to 1. So all we have to do is convert the double integral here into polar coordinates. Okay, so what is that going to give us? Okay, well, we know we're integrating with respect to theta last, so that means that the outermost integral must have the limits from 0 to 2 pi, and then the innermost integral will have the limits from 0 to 1. Okay, now since we got r dr d theta, well, we still got our r. And then if you look here, we'll have e to the x squared plus y squared. So we can essentially replace that with an r. And don't forget that the r here is going to be squared. And then it'll be dr d theta. All right. So hopefully that makes sense. So now all we got to do is evaluate this integral now. So remember, we'll integrate respect to r first, then with respect to theta, we'll work our way from the innermost integral here to the outermost one. That's how it works. So from 0 to 1, we got r e to the r squared integrated with respect to r. We do a u substitution. So obvious selection for u here would be r squared, and then du would be 2r dr. And then we'll end up with 1 over 2r du is equal to dr. So once we do our substitution, we can pull out a 1/2, and then we'll have times the integral, and then we'll have e to the u du on the inside. Now we do have to change the limits, but if we look at our limits here from 0 to 1, they're going to remain the same. If we stick in a 0, we stick in a 1. So this is, again, just one of those rare occasions, again, where when you change the limits, they actually end up becoming the exact same thing that you were given. That'll happen from time to time. So just keep that in mind. And so we just continue on. So 1/2 is a constant. We know the antiderivative e to the u is just itself, and it's going to be from 0 to 1. And this obviously gives us 1/2 multiplied by e minus 1. Okay, so now we move to the outermost integral, and we're going to evaluate that from 0 to 2 pi, and we're going to be integrating with respect to theta. So we'll have e minus 1 all over 2, and that'll be integrated with respect to theta. Now, since we're integrating respect to theta, there is no theta in here in our integrand. So that means that e minus 1 all over 2 is a constant. So since we're integrating that with respect to theta, and that's a constant, when we integrate that, that's just going to be e minus 1 divided by 2 multiplied by theta and evaluated from 0 to 2 pi. Okay. And we finish it up here. All right, so when we finish up, our integration, we'll have our answer that we were looking for. Okay, so let's go ahead and substitute in the 2 pi. Well, if we substitute in the 2 pi, well, it looks like we'll get pi multiplied by e minus 1. And then if we plug in, we're going to get minus 0. And obviously that's just going to give us pi multiplied by e minus 1. And that would technically be your answer. So your final answer for this double integral in polar coordinates. In our case, it was the integral from 0 to 2 pi, from 0 to 1, and it was r, e to the r squared, dr d theta. And our answer here is just simply going to be pi e minus 1, or pi times e minus 1. So when we integrate with respect to r first, we get pi times e minus 1. Integrate with respect to theta, we simply get 0. And so that's where pi times e minus 1 comes from. And that's your answer. So let me know if you got any questions about it. I'll be happy to address it. So see you next time.